and thank you for the introduction. Other health problems, mostly related to intramammary infection, are still one of the biggest concerns in dairy production. Early detection plays a key role in the management of intramammary infection and helping reducing the impact that it can have on the farm. When a heifer has intramammary infection and under-lactation, it has an impact being associated with an increased risk of clinical, assumed clinical mastitis, affecting the production, welfare, and longevity of the heifers, those heifers on the herd. Interfering also with the profitability and sustainability of the farm. Even having this knowledge, most of the times the herd health, the other health of pre-calving heifers is limited or even disregarded. And we have heifers entering the lactating herd with one unknown other health status. Infrared thermography has been used in human medicine for detection of breast problems and also has been validated to assess mastitis in adult animals, adult cows, in environment controlled. As a non-invasive tool, we hypothesize that with the results that we have been shown with experimental induced mastitis, that probably could use this tool to detect early detection of intramammary infection, and in combination with this, with herd management measures, we could actually reduce the impact of intramammary infection in the health of the udder. So the aim of the study was evaluate the usefulness of infrared thermography to detect changes on the udder surface temperature in nulliparous heifers under field conditions. And what we are expecting was that an increased temperature of the udder surface in the pre-calving time could be an indication of intramammary infection and elevated somatic cell count at the calving time. So we use one commercial dairy farm with complaints of heifers calving down with high somatic cell count and clinical mastitis. And we recruit 120 heifers in the last trimester of pregnancy. Each of these heifers was submitted twice to the thermography, 2 months before parturition and approximately 2 weeks before parturition. And in each one of these times, we did 2 different projections, cranioventral and 1 ventro-dorsal projection. The cranioventral projection, we did a straight line to the back quarters of the udder, and the ventro-dorsal projection in a 45 angle degree in relation to the hind limbs of the heifers. Both of the projections we did at 70 centimeters from distance. So then the thermal image were analyzed manually with different tools, geometric tools from the Thermocam Research Pro software, where we use polygons for the area of the quarters, lines for the teeth, and spot meter for the teeth end opening. So at calving, we took samples, individual quarter samples of colostrum for somatic cell count measurements and for microbiology. So we consider contaminated all the samples that had 3 or more morphotypes of colony per plate, and consider intramammary infection if we have 10 colonies of that morphotype in each plate. And then we did the statistic analysis with SPSCS. So in relation to the projections, most of the studies that I have seen, exception with one with dairy sheep, is very common to use the caudocranial projection or lateral projection for the front quarters. Comparing with our projection at ventrodorsal aspect, In both sets of thermographies, 2 months or 2 weeks before parturition, we had a strong correlation between two projections. In this case, we just consider the back quarters, because on the craniocaudal projection, we cannot assess the front ones. So this correlation probably shows that ventrodorsal projection can be an alternative projection to assess the other temperature surface. What could be interesting, especially considering the type of facilities that we have in heifer rearing units, that normally the animals are handled through a cattle race or through cattle crush. However, like was referred in the previous presentation, the analysis manually can be very laborious. Even though it's still taking the thermal pictures is actually on farm is easier, fast, and non-stressful for the animals since we are not contact them. And these animals, nulliparous animals, are not used to be managed, restrained like a lactating animal that every day goes to the milking parlor. When we tried to see if there was any individual parameter that we could relate with intramammary infection. And in this case, it is intramammary infection without clinical mastitis, just the presence of bacteria on the quarter milk sample. We have done a rock curve analysis, and we have not found that the data was good enough to discriminate between infected and not infected quarters. None of the parameters gave us a good result. So also the area under the curve shows a lack of accuracy and poor performance of the test. At the regression tests to predict the intramammary infection, we also show a lack of reliability. We also have to say that 90% of our isolates were CNS, coagulase negative staphylococcus. Probably the reaction, inflammatory reaction, and metabolism of the tissues and underlying blood circulation will be completely different that we have on the previous presentation with the E. coli mastitis, for example, or other major pathogens. We also could not detect, was not also reliable for detection of elevated somatic cell count at parturition. However, was an unexpected pattern of the maximum temperature of the quarters, especially the ones that normally we will think that will have the worst outcome, that are quarters that we consider with intramammary infection, with major pathogens, or with high somatic cell count. All of them presented as a lower temperature pattern than the other quarters with a less bad outcome. So to conclude, this study per se cannot say that we have evidence for using infrared thermography to screening as a screening tool for early detection of intramammary infection in pre-calving heifers with minor pathogens or elevated somatic cell count. However, I think is the unexpected thermal pattern in the quarters with high somatic cell count, major pathogens, and high colony forming unit, I think might deserve additional research, especially in a herd that will have more quarters infected with major pathogens or clinical mastitis cases at calving, that unfortunately in our case didn't happen, and field conditions sometimes we cannot, well, most of the times we cannot control if we'll have cases or not. But I think will be good to know to try to understand better what happened to the other surface temperature of dairy heifers, the pre-calving and at calving time. So this study was funded by University of Glasgow, and I have to thank to all collaborators and supervisors for all the support. and also to the herdsman for the sample collection, because at calving time, most of the time I'm not on the farm, and you have to do it by itself. And also to all of you for all your attention.
Thank you.